All right, good morning, good day, everybody. Today we are focusing our attention on the object serializer abstraction that we had in the books for a while. Finally, the right people are back from vacations or random things they have been doing. So I wrote this up basically as a reaction to some conversation I had with Christoph from the Azure Sdk team. Because they had a bunch of abstractions that were BCL-ish, and the question was, should we put them in the BCL so that we can all share the same abstractions rather than the Azure SDK having their own abstraction. And I think this abstraction came to be because the first version of the Azure SDK predominantly used Newtonsoft JSON, and then when they wanted to add support for system text.json, they didn't want to basically duplicate the API surface, and instead have an abstraction that allows you to basically just say, yep, here goes something that we may want to serialize later, like Cosmos DB, where you basically put in your own objects and then they serialize the objects on your behalf as they're manufacturing the message that gets sent back to the server. And I feel like when I wrote it up, I pretty much just copied the API shape that I think they had, and I think the only changes I made was the namespace. And as is hopefully apparent, this is not a proposal yet. It's just the idea that if we were to put it, it would be somewhere in system. Is there anything that I didn't cover, Christoph? Or is that kind of setting the tone?
One additional kind of maybe note about motivation. It's not only that we kind of want people to be able to pick which serializer. It's also for people who want to transition from existing libraries that used Newtonsoft. And because our new Azure SDK libraries ship with the system text.json serializers, but some customers already have data types that are serialized using Newtonsoft. And suddenly they get the Azure SDK library, they try to serialize, and there are very subtle behavioral differences in how the data types are serialized. So for them to transition to new Azure SDK libraries, they have to get back to the original semantics. And therefore, this abstraction basically allows them to say, well, I got the Azure SDK library, I try to serialize, I like the library, but I try to serialize my data types and there are some differences. I want to snap back to the old behavior, so they basically can use this API to plug in Newtonsoft. So it's more like it's a transition feature. And I thought it's interesting to kind of add this note, because I assume many customers who transition from Newtonsoft to system text.json would appreciate if libraries let them basically, we're using this abstraction and we're allowing them to change the serialization behavior through it. So that's one note. Second thing, I'm looking at the current APIs of our object serializer, and we seem to have more methods than you have. You have 4 overloads, and I'm seeing 6 on ours.
I mean, that's possible. I mean, as you can look at the date, right? When I created it, there was, I think, when you just had it in some of the API reviews, so it's possible that you just added more stuff after I created that issue.
Yeah, I don't. We have serialize. I see. We have 2 different overloads of serialize async and serialize. You only have 1.
I assume your other is generic.
Well, let me just copy and paste. chat. Oh, that didn't go super well.
Oh,
Let me.
did you just copy it in Teams? Yeah, that's never going to go super well.
Maybe this will work better. No, that doesn't work better. Anyway.
Oh boy, I can try to make it pretty. And to be clear, this abstraction is not meant to just abstract JSON, right? It's meant to abstract any serializer, right? So it could, in principle, be used with binary formatter or Protobuf or whatever serializer it is, right? It's just, here are some bytes, give me an object, or here's an object, give me some bytes, right? That's effectively the contract of it.
I'm not convinced that's true. I think your example of Protobuf, I would be very surprised if this could actually accurately represent Protobuf. I do not think it's possible.
Why do you think that?
Well, Protobuf is a kind of index-based field serializer. It's going to require more information than is just in the token stream. It's not good enough to hand it an object and say serialize. You have to have the actual Protobuf file that shows the tags.
Yeah, so this information, the idea is that it would be provided when you construct the serializer.
So then this API is somewhat incomplete in that sense.
Well, it's an abstraction, right? That would be a Protobuf object serializer that derives from that would, in the constructor, take whatever it needs to take, right?
Yeah, because there is always, for concrete serializers, there will always be some information that is specific to the implementation of the serializer. So for example, for JSON, there are all the JSON options or settings, and you provide them during construction. And same with Protobuf, you would provide them during construction.
So I guess you would lose type safety in the sense that you construct the serializer for a specific type with the data that's necessary, and then afterwards you can pass any object in there, but really it only supports serializing a very specific type.
I don't know if it means specific type or specific set of types, but yes.
Sure. At minimum, you've gone from a cardinality of an infinite set of types down to a finite set.
Yeah. Having said that, I mean, isn't that a property of Protobuf in general?
No.
I think it's a property of, any serializer is going to have limitations on what types it can serialize. It might be implicit to the nature of the serializer, or it might be implicit to how it was constructed. Like, there's only a finite set of types that you can serialize with Json Serializer, for example. There's only a finite set of types you can serialize with binary formatter, for that matter, right? Things that have been attributed appropriately. I think the difference in this case is it's not inherent to the serialization mechanism. It's inherent to what information was provided to that concrete instantiation of the serializer.
Yeah, in a way, the idea of this abstraction is basically to just allow a library to say, you can just pass me an object, and I will serialize it with a serializer that you provided either in settings globally for the client object, let's say, or you pass it in, and then the serializer or the library is free to serialize later, right? Which kind of removes a lot of the ceremony that you would have if you would, let's say, take Cosmos DB. You want to say store document, retrieve document. You want to pass in your actual instance of the document. You don't want to have every single call site have to deal with serialization, right? But now, in order for that to work, you kind of need to let Cosmos DB know, okay, how would you like to serialize this thing, right? What serializer do you want me to use? And that's basically what this thing would do, right? It would still mean that, yeah, if the user wants to use, let's say, Newtonsoft JSON, and they want to customize, let's say, how properties are represented in JSON, well, they would have to use the Newtonsoft JSON attributes for that, right? And if they use ours, well, then that won't work if they pass in the Newtonsoft object serializer instance to the Cosmos DB API, right? So it's still, yeah, the user has to basically still have to attribute their types correctly or author them correctly to the spec of the serializer, and then they have to choose the correct serializer that they pass into the parties that are supposed to call these APIs, right? So there's
that seems like part of the problem with this abstraction is it's both the producer and the consumer of the instance need to coordinate. So the types that you're passing in are generally attributed for a specific serialization framework, and it'll only work if the matching serializer is provided.
Yeah, this is kind of just my type safety argument.
Right.
Again.
Yeah, I'm agreeing with you, Andy.
Well, but I mean, I don't know how you would solve this because I mean, virtually all serializers don't have type safety at that level. Like the compiler wouldn't be able to tell this
It's
type
not even
is
type
not.
safety though; it's correctness. If you give me a serializer that's Newtonsoft JSON, I've attributed myself with attributes based on system text JSON, you will not serialize my types correctly.
No, I get that. All I'm saying is that ignore the abstraction. That problem exists today, right? Like the serializer can't tell at compile time that this type is correct unless you say, oh, we only talk about serializers that do source gen, which is not the state of the
No,
world.
I understand. I'm saying you can't ignore the abstraction. We're talking about the abstraction, and I think the abstraction is faulty in that regard because it's implying a level of distance between the producer of the instance and the consumer of the instance that can't actually exist.
But I think it's useful to kind of talk and look at real scenarios, like how it works in libraries. So again, going back to my example of transitioning, let's say Cosmos from Newtonsoft to system text JSON, basically Cosmos clients would have a property that is object serializer type. I'm hand waving the details, but imagine that on Cosmos client, there's a property called serializer, and the type of this property is object serializer. By default, the property points to system text JSON implementation of the serializer, and that's how most of our customers use the Cosmos library, and they are happy with it. From time to time, there's a customer who wants to serialize types that they used to attribute from Newtonsoft, and now with the Cosmos library doesn't work for them. They can basically assign Newtonsoft implementation of object serializer to this property, and suddenly Cosmos library works for them just fine. So it's a real scenario. It works. I'm sure there are many limitations of abstractions, as you know, any abstraction will have some limitations, but it works in non-trivial set of very important scenarios.
Can I try and parrot that back to you, Christoph, to make sure I understand the scenario? I think what you're saying is, I, as the user of a particular library, there's a library that accepts a serializer, and it accepts instances of types from me, and it will only ever try to serialize my types with the serializer that I have provided to it. It's the one that's calling the serialize, deserialize methods, but it's only ever doing so with my input, and therefore it's up to me to make sure that those two things match.
Yeah, basically the library that uses this object serializer will have methods like, save that takes, your instance, and it will just run it through the serializer to produce the bytes and then pass the bytes along.
It's also worthwhile saying that's kind of how ASP.NET works today. An interesting thing for ASP.NET is there really isn't an API for a customer to conveniently say which serializer to use, right? Because if you write, for example, the web API style API where you have a post method, right? It's all based on conventions, right? Your method ends in post. You return an instance of some type, let's say IEnumerable of customer, and then the framework is basically on the hook for now calling the serializer for you, right, on your behalf. And there is effectively a global API that you can basically use to say, well, I want ASP.NET to not use system text.json. I want it to use Newtonsoft JSON, right? And there's a NuGet package you can bring in, an extension method you can call, and it has the same property that you described, Stephen, where effectively there is a huge difference in terms of where you configure this and where you actually end up using the serializer, right? But that's, you could argue that's a problem or a design fault. You could also argue that's part of why it's, an attractive programming model that ASP.NET provides, because when you actually implement the web API, you don't have to deal with the mechanics of the serializer, and you just have one central place where you can say, oh yeah, swap out system text.json for Newtonsoft JSON, right? So it's a bit in the eye of the beholder if it's a limitation or a feature, I guess.
But is it portable in the way you describe? Like,
well,
I
it's
understand
portable in the sense that in your app you control it, right? And so like
no. Portable in the sense of you stated Newtonsoft.json and system text.json. I'm asking whether it's portable in the broader sense. Like, can you actually swap in any serializer and expect it to work? is it fulfilling the promise of an abstraction, namely that it can be implemented for a variety of different serializers, or is this actually very specific?
Well, it depends what you mean. It will just work. So if
Yeah.
what by work you mean that object will be converted to bytes, that is true. It will work. If you mean the format of these bytes will be interchangeable, of course not. That is almost the whole point of the.
No, that's
feature.
not what I was saying. I was saying, are there examples of this being used to transition from something like, or are there examples of this being used for Protobuf?
Well, not in the context of Web API, because fundamentally, like you need to produce JSON, right?
Oh,
Or
that is
XML.
Or
That is not
XML,
true.
yes. I guess that's
No,
true.
no. This is not true. You don't need to produce JSON, or it converts anything to bytes. It converts objects to bytes.
Well, I mean,
So-
in the Web API case, because when you have a controller, like there's I guess there's a MIME type, right? And so long, I think the MIME type is, I think, part of the abstraction ASP.NET has, because yeah, it's XML versus JSON versus whatever, right? But like fundamentally, now the question is that abstraction could have been written in terms of, here's a MIME type, give me an instance of object serializer you want me to use, right? So like in that sense, it's portable.
Well, I'm asking for an actual example of somebody having written a like Protobuf style serializer using this API. Like a proof by example. Like show me a non-system text JSON or Newtonsoft.json implementation with this API.
I mean, I'm confused by what you're asking, because I mean, if you're saying you don't believe that you can actually derive from object serializer and have an implementation that is baked by Protobuf, I mean, the intention wouldn't be that Protobuf is using object serializer directly, right? The idea would be somebody, maybe Protobuf themselves, but like in principle, the idea is that it's glue, right? You basically derive from object serializer and you basically pass the data through to Protobuf, right? So it's kind of an, it's similar to IEnumerable in the sense that it's an abstraction, but you basically say like there's some glue that glues them to whatever data types that you actually have, right? So like in principle, I don't see why it wouldn't be possible. I mean, we can certainly write an implementation for it that would do what you think it does.
Yeah, I'm mainly concerned that if we don't actually have some other implementation, then we could be biased towards two particular serializers.
Oh, for sure. I mean, but that's also why I think the API ship is kind of the way it is, right? Because it just deals with the bare minimum that you would think, you would ever have to know, right? You given an instance and a type, give me back some bytes. Given some bytes, give me back an instance of this particular type, right? That seems kind of intrinsic. I mean, the only problem that we have here, which is what we discussed on the thread, is that the way the interface here is defined is that it's all effectively not friendly for static generation, right? Because it's all in terms of object and system.type, which basically means it's implicitly requiring reflection at runtime. It's very hard to, or I would say it's probably impossible to tool this. And that's kind of a limitation, but I think that's just the reality of today's serializers for the most part.
I don't think that's true for system text JSON, right?
Well, I mean, given that we literally just added the source generator and it still has a lot of limitations that the dynamic system doesn't have, I would say it's also true for system text.json.
No, I mean the system text JSON API that is currently shipping, the non-source generated one, is supposed to not be polymorphic except in limited circumstances. I mean, the tagline is it doesn't support polymorphic serialization.
Sure. I mean, I guess it depends on what you mean by dynamic system, right? I mean, the idea is still that if you call the serializer with an instance of object and type, it might not be polymorphic at runtime, but it's polymorphic in the sense that at compile time you don't know what actually types flow through the system, right?
That's not how it's supposed to work. It is supposed to take a generic instance and then it's supposed to serialize exactly that instance. If you subtype, it's not supposed to serialize the subtype.
No, there's still the different API share, but there's an API ship that takes an object and type, and there's an API that is a generic. Like they both behave the same way, as in they're constrained by the supply type. All I'm saying is that if you look at how people use system text.json today, it's similar to to Newtonsoft JSON, where in many cases, the call side isn't generic. In many cases, the call side actually does take an object into system.type, in which case you don't know statically what type it is. You just know at runtime, the payload is constrained by that type, right? So it's
right. I'm just pointing out that I think that usage is discouraged according to the documentation.
Well, it is discouraged. All I'm trying to say is there's a difference between what we would like to see and what the ecosystem de facto does, right? And the fundamental challenge that we have is that, similar to async, the problem with generics is that they're viral, right? And so, like, if you look at how code plumbing works for many apps, it's just not viable for many people to call the generic overloads, because at the time where they have to call it, they no longer have a generic. The only thing they have is an object, and if they're lucky, a system.type that actually tells them what instance to use. And that's why that's why I'm saying, like, if you look at the history of serializers in .NET, I mean, Christoph and me and many others on our team tried to effectively kill serialization for, like, quite a while. We try to get reflection out of the core, right? When we try to do that, you run into this problem that real world .NET user code is just so dynamic in so many cases that it's just really, really difficult to just say you need to be, generic, and we need to know the types in all cases, right? And that's why the abstraction looks like the way it does, right? I mean, you could imagine this abstraction being completely generic, but then the Cosmos DB folks would have a hard time plugging that in as well, because now they would have to be generic as well.
Yeah, there's a difference between, like, saying we added support for the dynamic case because, unfortunately, that is how a lot of things work, versus we add an abstraction that can only use the dynamic case, despite us thinking that that has serious limitations, and we're going to encourage people to use it. Like,
I
the
think that's fair.
systems have to be built in both ways. It's both a description of how people use them, but also it's an intentionality thing. Like, if we think that people should use them in one way, we should build APIs that encourage people to use it in that way.
I think that's true. I think that, to me, there's not a reason why the abstraction couldn't have generics.
Well, the reason, so in addition to the object overloads, generics would be just fine. But a lot of, for example, Azure Sdk higher level libraries like the Cosmos library, they are not generic APIs themselves. They take objects, and therefore we then have to call the object-based overloads if we want to convert the object to bytes.
Yeah. I mean, at minimum, the base class here, adding a generic or virtual generic serialize that then calls the abstract object and type based serialize would then, like, that's missing from this.
It's just, I'm not clear what it would, because it wouldn't solve the problem of statically not being able to see what is the set of serializable types. And so it wouldn't solve the problem that we just started to discuss. And the only thing those generic methods are, they are just syntactic sugar at that point.
I mean, they also avoid quote unquote suspicious casts of object being hard cast to a concrete type. You have something that says this was done right because the runtime won't allow it to be wrong.
Yeah. I think the question is, I mean, I'm trying to echo, like, the concern that Andy has, which I think is still a thing that we need to kind of reconcile with the design here, is like, so let's say Cosmos uses this abstraction, which I assume they already do, because I think you already shipped Object Serializer in the Azure SDK, right? So if you now have a customer, let's say a big customer like Exchange or somebody who actually happens to use Cosmos DB as an implementation detail, how do you make it so that the app or the library or the service, whatever you want to call this, is trimmable in principle? Because if everything is expressed over a type, then effectively you would have to say, I don't know anything, I have to keep all the metadata around just in case, and then, or I do the good old Windows 8 store scenario where I have a ginormous RDXML file and I try to handpick what I think is safe, and then eventually I get to an app that works. And so I think the concern is that if we have an abstraction and it becomes widely used for core libraries, we don't want to end up in a world where now I guess the premium libraries that we have, like Cosmos DB and other Azure SDK offerings, become untouchable. and or untrimmable, or not great for these kind of scenarios. But if you think of web API, not web API, sorry, if you look at WebAssembly or Xamarin, where trimming is effectively required for decent perf, then that will be unfortunate, right? We don't.
But the thing is that, I mean, to me it seems like the ship has sailed 20-something plus years ago. Like we have, the runtime is a very dynamic system. So I think it's great to think how to make the trimming better and the scenarios. But I don't think it's we can pursue 100% trimmability guaranteed by all the APIs in BCL. I mean, we have system.object already in the BCL.
Well, I don't think that's what we're saying. I think the question is, if you look at an API design where you have generics and dynamic methods and we have attribution, you can say, well, things are linker friendlier if you call the generic ones. And so you can have an analyzer that says, oh, this API isn't linker friendly. And then for application models where basically linking is effectively part of the experience, like WebAssembly or Xamarin,
sure,
those will be on by default, right? So like we don't have to dumb down the system for everybody, right? But the question is, if I'm in a scenario where I need linker correctness, how do I get there without effectively having to replumb the entire theory, right? And I think that's the current abstraction as it's proposed would basically say like, oh, sorry, you're never going to be linker friendly. So if you have any call size to this, you're basically screwed. And I think that's kind of the concern if we say Cosmos is only using Object Serializer.
I see. So basically you are saying, well, I agree with what you said. Like if we add generic methods in some scenarios, they will be more linker friendly. I agree with that. What I wanted to say is Cosmos, it will have no impact on Cosmos because the serializer is called in the guts of Cosmos.
Right.
Which makes sense why this is this is the Azure SDK API. But I think that the whole premise of this is that we should, if we want to have an API extend all the way into .NET Core, then we should make sure that it's workable for .NET Core as a whole.
Sure. But I think the only thing that I'm wondering if you're thinking you can remove those methods that take objects, because I believe you cannot. It has nothing to do with Azure SDK. It has all to do with many high-level libraries, not Azure SDK, other libraries. They often don't want to be generic. They often take objects. So if the generic methods are an addition that you're gonna make when you move this type to BCL, I think it's a good call. If you think you can remove the overloads that take object, I don't think that's a good move.
No, I don't think that the use of kind of dynamic type checking and reflection in .NET Core or anything else is going to go away anytime soon. But just like looking forward, at minimum, I think we should support the systems that we're already building for reflection. So the new system text JSON APIs that use source generation, I think that should be, that was a huge amount of effort for a lot of different scenarios, and we should make sure that we're not kind of dropping the support for our flagship APIs in our flagship abstraction, if this is going to be our flagship abstraction.
Yeah, because whether it goes through the generic one or it just dispatches to the current abstract ones, if you've run the source generator for your types and you're trying to work with this, you basically have to write a type switch-a-fall to say, if I asked for this type, then dispatch to this pre-generated type. We may have built that in with the generated output, but that's basically the model that you'll have to build is a derived type that says, here are all of the input types that I support, and here's the code that you should run when I get this one. Because our new model is to basically not have serializers. It's to just have a way of serializing your type, which is a serialization method instead of a serializer framework.
By the way, one thing that I wanted to make sure we don't lose, there are some comments, and I saw people having hands up in the chat. One interesting one is we had a discussion about implementations of this abstraction. And Pavel commented that there's also, I forgot about it, in Azure SDK, an implementation that uses Avro as a format. So yes, it's not, Protobuf, but it's actually kind of similar to Protobuf. It has there's a header section, and then it can be either text or binary. So there is more than just JSON implementations of this abstraction.
Yeah, if we say flagship abstraction, I mean, that might also be a bit overselling what this is for. Like, the way I see it, at least, and I think the way the Azure SDK has been using it, it's not so much meant as, if you do serialization, you should use this thing. It's more for if you happen to use the dynamic serialization mechanisms that we have, then this abstraction allows you to plug in others or let the users plug in others, right? So it's not so much the the last final thing to do. It's more the idea that we are adding value by basically saying we recognize where the ecosystem is, and we make it possible for people to do what they are already doing, right? We're not making the world fundamentally different with this abstraction, right? I mean, you could imagine that we have a different abstraction for source generation, which I don't know what that would look like, because fundamentally that is way harder. And I think the problem that we still run into with system.text.json, even though we just designed it, it is very clear that retroactively trying to make something source generatable is actually quite difficult, right? And so we went through this exercise and tried to make the programming experience decent with system.text.json, but there's still limitations that are very fundamental to the fact that we need to know the type closure at compile time. And so that is something that I feel like in a perfect world, we would have designed system.text.json from day one with source gen in mind, but we didn't. And so this retroactively adding on top is what's difficult. And I think that is a problem that pretty much all serializers have. Some, like Protobuf, are kind of designed pretty much from day one of saying, no, there's a schema, the schema is fixed, and it's independent of your type shapes and blah, blah, blah. And that is, of course, more friendly for generation, right? But I think like most serializers aren't like that. Most are very ad hoc, where you walk an object graph and you make up stuff as you go, and then you introduce some attributes or some random callbacks, and that's kind of how most serializers are. And so I wouldn't necessarily say that this thing is the future for everything. It's more like make the existing world a bit more exchange friendly. I think that's how I would see that. Which I think adds value, right? So to me, this is why I say that we don't have to dumb down the world just because this new thing doesn't work well with everything we have, right? It needs to be work well enough and add value, I think, in order to justify being in the BCL, which I think it would.
Do you have a list of places that we would implement?
You mean list of places where we would use the serializer abstraction?
Yeah, like, are we going to put it on system.text.json? Are we going to put it on binary serializer? Probably not. But, data contract, XML?
Yeah, so I would say system.text.json for sure, obviously, right? Because that's where it's already being used for. Data contract with XML I can see, or XML serializer for that matter in general, I could see. Binary formatter I don't think we would touch for all the right reasons. And then I would think that maybe in ASP.NET, where they actually do talk about the serialization mechanism, that would maybe use that abstraction over what they currently have. Or in addition, I guess.
In that case, I wonder whether it's backwards. In the sense of, we know where we'd like to implement it. Why don't we do that first rather than add the, you see what I'm saying? Like, we're adding the abstraction before we actually implement the abstraction, but it seems like we would want to do them together.
Well, for example, like system.text.json, JSON Serializer, as Eric pointed out offline, is like static methods. So we're also talking about introducing a new derived class here.
Yeah. I mean, this is not meant to be a discussion for let's just approve what we have, right? This is meant to be a discussion of like, do we think we want an abstraction at all, right? So I'm still like kind of at step 0.5, if you will, right? But I mean, in general, I agree. Like, if you have an abstraction, you ought to have more than one implementation to actually verify that it's a useful abstraction. I kind of waived it a little bit in the sense that the Azure SDK already has implementations for systemtext.json and for Newtonsoft JSON. So in that sense, it's proven enough to be, useful as a discussion. I don't know what the quality is. I don't know what how many scenarios it can handle. I assume it does it all, but that could be wrong. But I mean, that would be my starting point, looking at the implementations and then seeing whether we can move them as well. Or at least the systemtext.json one, obviously.
Yeah, but at the same time, like I'm sure the implementations are actually quite good. I mean, I haven't looked at them, but the developers working on them are great. I think the question would be, does it meet the more generalized needs? I mean, like to the points I made earlier, systemtext.json has been evolving in a way that is focused on trimmability and the like, and is our introducing a new systemtext.json object serializer going to push the in a way that ends up violating those desires, violating the goals of pushing people to actually use the source generator and so on. There's a lot more to be proven out other than it's possible to wrap systemtext.json and derive from this type.
And similarly, like the implementing usage point I was trying to make was that really it should be both sides, that we should find the places that we would actually use the abstraction. And I think, Cosmos is great, but they already have the abstraction. What are we really gaining there by adding it to
so
the
I was using
core app?
Cosmos as an example. We literally have probably already several services that use it, and new one is being added every quarter or so. And of course,
And so
doing what we are doing, we can keep using the Azure SDK abstraction, but then it means we now have our own implementations of the abstractions for both Newtonsoft and systemtext.json. And when we do Avro, we basically it's because we have this abstraction and it's Azure specific. Now it kind of the gift keeps giving. We keep being in a business of creating serializers.
What? Yeah, but then we would want to find a different usage of serializers that's not Azure in order to validate the generalized value for NetCore app as well, right?
Sure.
Why is there a dichotomy here that it's either it has to be Azure SDK or it has to be .NET Runtime? Like, why can't this abstraction live in a middle layer in between those two things?
What is the middle layer?
I don't know. Call it Microsoft.serialization. New library defines this abstract class. If there's usage of generally purpose one, maybe there's a Newtonsoft or systemtext.json in there. Implementations, if there's built-in ones that we need in that library, but then there can be extension libraries too from it.
So actually there was I don't know if you are on this email thread, but there was an email thread, I know Peter, Dan, and some people from your side and some people from our side are on the email thread. And we were discussing this exact issue, which is we have libraries, basically currently we have libraries that are in the BCL or in .NET platform. We have libraries that are in Azure SDK, and then we have random Microsoft libraries on NuGet. And today the problem is that some things are so general purpose that they don't belong to Azure SDK, but the BCL team is not willing to kind of take ownership of these libraries. And the third alternative, random library on NuGet, the problems that these have are that people use different patterns. They are random teams at Microsoft ship very opinionated libraries that don't follow really design guidelines, some principles, how you build them, how these things should version. So there was an idea of creating a repo that would be kind of good Microsoft libraries. And maybe they go through some light API review like this one. Maybe we kind of, collaborate. We have a shared API review or Microsoft-wide API review. We set up static analysis tools in this repo. We set up a build system such that NuGet packages are very consistent when they are deployed. That is an idea. I don't know who would actually make it happen, but I think it's something worth considering. And if we had that, you could argue that a type like this should be there.
I mean, kind of one of the reasons why I posed this question is because I don't know of a different programming platform that would put something like this in their core libraries, right? Like Rust has Srd, but even that's not built into Rust, right? Like that's a separate thing. I mean, granted, we've kind of lived with 20 years of anything that's general gets put in the BCL in .NET, but do we need to keep doing that? I don't know. Maybe this isn't the flagship for that, but I keep seeing this problem.
Well, we try to create a trimmed down core.
Well, I mean, to me, it's kind of, there's a difference between putting more shit in the core, like, somebody on Twitter recently asked for built-in YAML, for example, right? And having abstractions that are fairly lightweight to allow others to provide stuff. And I'm way more sympathetic to the latter and way less sympathetic to the former.
But why does the abstraction need to live in the BCL?
Because that is a fundamental property of .NET not so much as a culture, which I think the culture is the YAML problem because everybody expects us to provide it. The other problem that we have is the type safety and the way assemblies work, right? So the problem is if somebody else needs to ship an abstraction, it's effectively yet another NuGet package. It's yet another library. It's yet another moving piece in the system, and that causes friction. And so far, we have done a lot of work to make the binder less, more forgiving. We have tried to make NuGet dependencies, less annoying. But fundamentally, nobody likes more moving pieces, right? And that's, I think, a fundamental property of our type system and delivery artifacts. That has nothing to do with culture. That is just to do with, do we want this? And we know, that people complain all day long, and we are debugging these problems all day long too, right? And so it seems to me it's easier if especially when it's a single type, because putting a single type in NuGet package is never great. And so there's also a pref argument. I mean, there's many other cases where it seems desirable if the thing is really small to just add it, right? But if the thing is kind of exploding in complexity, like a YAML parser, for example, there really is no reason why we need to put this in the BCL.
But in that case, all those problems you just listed means it would have to go in the shared framework.
Yeah, probably.
Right? Because if it's an OOB NuGet library that ships out of the .NET runtime, it's really no different than an OOB NuGet library from any other repo.
Right. I mean, this is the kind of the other problem that, every time Christoph and I talk, right? It's yes, we can put it in the platform, but no, it doesn't help the Azure SDK because they need to run on .NET Standard 2.0, right? So, but there's a difference between, the current system of the world and then the customers who happen to be on .NET 6, .NET 7, .NET 8, right? So at least you can say, well, it is in the box eventually. So given enough years, the problem will disappear versus given enough years, we just have more and more assemblies, right? So I think we just put a ceiling, basically onto the problem space, if you will.
But binary data, right? Binary data falls in this exact pattern.
Yep.
And we didn't put that in the BCL, as far as I know.
No, we didn't. But I think to me that's also kind of that has a different problem, right? I think the reason we didn't put that in the box is because of dependency problems, right?
I'm also not sure if that's true. What do you mean we didn't put it in the BCL? As far as the ecosystem is concerned, it's in the BCL. It's not in the shared framework, but it's in the BCL. And I think that is the middle ground for some of the APIs. Like Object Serializer that is in Azure SDK basically means there is not a single abstraction for .NET developers to implement, these mappers that maps objects to bytes. The moment we put it in system namespace, it can be a NuGet package. But if we put it in system namespace, there's an API review in this forum, it's approved. It kind of, it communicates to the developers in the ecosystem that this is the type. It's basically, endorsed by this team. And I think binary data is like that. It's not in the redist, but it's endorsed. Is the way, it's a simple holder of bytes. And I think object serializer endorsed by this group would, be treated similarly by the community. The question whether it's something is in the shared source or in the redist or not, that has only implications whether the existing BCL can use this type. So for example, binary data, because it's not in the redist, cannot be used by the redist itself. And because the redist is very large, it means very large set of APIs cannot use binary data. If we put object serializer in the redist itself will be able to use it, and if not, redist won't be able to use it.
Yeah, to me, Eric can correct me, but it sounds to me as if what Eric just suggested at this middle ground and what you just said is virtually the same thing. It's just now the difference between system dot and Microsoft dot, right?
Yeah, but I'm saying system dot is the endorsement, basically.
Yeah, and I think that is I think this goes back to what I said earlier about more like the cultural thing, right? I think for things like an abstraction, like an object serializer, I think that's probably fine, because I think that's one of the examples where you kind of want fewer things anyway. And I think an abstraction fundamentally is having an opinion, right? And you will cut off some scenarios and that's fine, but you're adding value by providing an agreed upon abstraction. The problem with things like YAML parsers is that you kind of want to say well, do we really have to have an opinion on everything? Or could we just say the ecosystem is diverse and there's multiple different YAML implementations and you pick the one you want? And I think this goes a bit back to how other ecosystems work, where you don't have to have an opinion on everything, and then some people like this, some people like that, and that's fine. And I think that's generally okay, especially when you have good enough core abstractions so people can at least exchange stuff. They don't have to agree on every single type. And I think that to me would be the middle ground. I would say for heavy implementations, yes, Microsoft doesn't have to provide everything. Not everything has to live in system. Even if it's provided by Microsoft, it could just be a random NuGet package that is called Microsoft.opinionoftheday.NuGet package, right? And those things might not last as long as system stuff does, and that's totally fine.
By the way, speaking of which, to bring it a bit more concrete, let's assume that we approve this type, we like the shape, we like the type. Which binary would it live in? Would it be in system memory data, or it would be somewhere lower, or it would be somewhere higher?
I mean, to me, that kind of depends on the abstraction, right? I mean, binary data, because its implementation depended on system text.json, we knew it would be very high, right? This one here, if we're looking at the API shape, it pretty much depends on only stream, so it's fairly low level. So it could live virtually anywhere we wanted it to live in. I mean, in order for us to be able to give it to you for Net Standard 2, it would probably have to go in its own assembly, would be my guess.
But I wonder whether so I think, putting it very deep in the core has the benefit of now .NET platform itself can use it.
That's true.
Putting it below system memory data, but not in the core, I know what you said, that system memory data has dependency on system text JSON, but I think that's okay. System text JSON is big part of the platform, and I think if we start refactoring and creating those very small DLLs, just because this one doesn't have any other dependencies but stream and very core types, I'm not sure if there's enough value.
Well, I mean, to me, there's two different views, right? There's the, I mean, this is not going to .NET 6, right? This is going to be future or .NET 7, let's say, right? There's the .NET 7 view where if the thing ships inbox, where do we put it? And then there is the where does the OOB live discussion, right? And they are almost independent, right? And so we could decide that the OOB identity is its own assembly, and then the inbox assembly is actually, let's say, we could go all the way down and put it in system runtime if you wanted to, right? I mean.
But maybe I missed something. I would say the OOB identity could be system memory data. I'm not sure if.
Yeah. I mean, we
need yet another small assembly with one type. Yeah.
Yeah, that's fair. I mean, given that this thing already depends on binary data in the API shape, which I just realized, it couldn't be lower than binary data.
Well, I mean, that depends on whether or not we refine the shape. But
Yeah.
the yeah, I mean, like we could put this all the way down in corelib, and yes, then the rest of the shared runtime could use it. But to go back to Andy's point, I don't think there's anywhere that we would want to use it. We don't generally have give me a thing and we'll do load save for you. That's what this is for. So it, you know, most of the shared framework is functional. And
Right.
while there were a few things that basically do load save, that's essentially .NET remoting, and that's gone. And so there's no benefit to being in the shared framework. And our current rule that I understand is if we don't need it, it's not allowed.
So I have a question. You guys added those HTTP JSON APIs, like you can basically do HTTP call and it automatically serializes some object into JSON request content. Where are these APIs?
Yeah.
Because this is basically the same scenario as our Search or Cosmos.
It's these guys here, right?
But where does it ship? Is it in the Redist or it's not? Or it's just a package?
No, it is. It's part of .NET. It's since .NET 5 it ships in the Redist and it's in its own assembly. It's in system.net HTTP JSON.
Yeah. So you see, like for example, this feature, I think it would be good if it was using the serializer. It would allow people to control how their objects pass to these methods that Timo is showing on the screen end up being serialized.
Serialize it into XML. It's called JSON, right?
What?
Yeah. So if you look at the API,
this is JSON, right? Like it's get from JSON. Why would I want to pick some other kind of serializer? Is it just because we have two JSON serializers?
Yeah, and then there's actually not two. There are many probably JSON serializers, and it allows people to use this feature, the HTTP JSON, whatever the feature is called, HTTP client JSON. Yeah, it allows customers to use this feature with JSON serializer of their choice. And in fact, the APIs are called JSON. I suspect there's nothing JSON about it. The object is just being serialized and pushed into the request content, or when it's deserialized, it's pulled from the response content. So it could work for XML services.
Well, I suspect that it sets the MIME type to application.json or application/JSON. So probably if you produce XML, bad things will happen. But
maybe.
Yeah. And then the overloads of this are system text JSON configuration objects, and we could make another one that took an object serializer, but it doesn't need to live at this level. This was all done as extension methods. So wherever object serializer lives, it can just slap another get from JSON async extension on HTTP client. Like they don't have any reason to be co-located.
Anyway, imagine that you wanted to add ability to this feature to let customers select custom JSON serializers. How would you do it? You probably would do it through something like this object serializer abstraction.
I mean, maybe. I mean, the problem with these APIs is that they're really meant to be this, one single line kind of thing, but they don't. I mean, they save you like 3 or 4 lines of code, right? That's really what they're for, right? So
do you expect to use these from Blazor, because they're all requires unreferenced code? I don't know. I think that the answer would probably be no.
Well,
in fact, if you use Blazor, the recommendation is don't touch these APIs ever.
Well, we also have overloads that are generic, right? Like this one here, for example. So, I mean, yes, they were meant.
The current proposal does not have the generic version, so that's what I'm saying. It would be equivalent to.
Yeah, we would. I would think that if we have generic methods, we would make the generic overloads plumb through the generic ones, right? And then this way it would close that. But I think the question is, I don't know. We would have to look at sample code, but my gut feel is these ones here that actually take, the JSON serializer options is already not the most popular because it's making this thing more and more complicated, and it's really meant to be more like the single line kind of implementation of your service, right? If you do anything that is actually substantially interesting, you probably don't call these APIs anyway. You basically construct the serializer directly. Because these ones are really like immediately calling the serializer, right? They're not like the Cosmos DB one where some significant amount of work is happening, right? They're just really meant to be save you the 2 or 3 lines of code that it is to actually call the serialization method. But yeah, I mean, it's a good point though. Like this one, I mean, to the earlier question of like Redist, I mean, we don't have one Redist, right? We have multiple layers of shared frameworks, right? So the way I see it is, the Microsoft Net Core app, which is the for all intents and purposes what 5.0 represents, basically what's auto reference when you build a console app or a class library. An abstraction would still add value, in my opinion, if other shared frameworks that sit on top would use it, right? So, for example, imagine there's a shared framework for MAUI, there's one shared framework for ASP.NET, and they both want to use it. Then it might make sense to put the abstraction into the shared layer, even if the shared layer below them doesn't actually use the abstraction themselves, right? And I think it's fair to say that, the Microsoft Net Core app is probably not very likely to use the abstraction, with the exception for this API, for example. But like for the most part, I would expect this to be plumbing. And then the app models would have no opinion on, and they might actually use it. And if multiple app models are using it, to me, it makes sense to have it in Net Core app to remove duplication. But yeah, there's fundamentally nothing wrong with saying ships as a NuGet package, and then let's say the ASP.NET shared framework has it in it, but Microsoft Net Core app doesn't, right? Those are the decisions that we can make. And I think in general, like if you do build an abstraction, I would start with an OOP just in order to get some feedback. Work with other third parties as well to make sure that they can implement their stuff on top of it if they wanted to. Christoph, did you actually, you own the Newtonsoft JSON implementation, right?
Yep.
Did James take a look at that, or?
I don't remember. Is Pavel may know, because I think he actually implemented the concrete type.
I want to say yes, but don't quote me.
Well, you just said it live on air, so everybody heard it.
I think the thing for me would just be if it's JSON related, I could see a wide variety of reasons why you would want to use it in Blazor. And so if that's the direction we want to go, then it's got to be trim compatible.
Yeah, I mean, so do we want the concept as a shared abstraction or not? I'm kind of personally on the fence. There's another question of do we have the right abstractions here?
Right.
Which also came up in the YouTube chat of, is stream really what we would base this on? Like a lot of work has been done recently to reduce object allocations, and if you have a span, now we're saying you have to take the span and write it into a memory stream to pass it into deserialize, and well, but why couldn't deserialize just take the span? And that would also have impact on layering decisions and the like, but so I assumed that what we were talking about in this hour was what's the value / cost of the concept. And so
yep.
Aside from mentioning that it's not trim compatible, but then we could fix that with generics, I assume we haven't been looking at the individual members.
Yeah, I think that's the discussion that I was trying to have.
And you can fix it with generics, but you got to be very careful about it, as the results from like the source generation show. Like it's tricky. I wouldn't underplay the amount of API design that would need to go to make it.
And in particular with trimming, I don't know if we still have Eric E here, but like if it's virtual and generic, that the default behavior is to dispatch to the abstract that is not trim compatible. I don't know how we would annotate that. I don't know what the
it would have to require some reference code.
Yeah, at which point it's now not linked.
It's not
trim friendly, and now we can't call it from anything that we care about trimming in, even though it could be in the specific instance be trim friendly. And so this is where our current drives get weird with virtual.
And so at the other end, if we decide that we build an abstraction that we don't think would ever be usable in Blazor or something like that, then go for it, right? But it's just I didn't see a reason why we would think that these things wouldn't be useful in Blazor or in mobile apps or anything like that.
Yep. I mean, we already had the discussion, I think, when I mean, we initially built the HTTP client extension method specifically for Blazor. And then when people tried to use the linker on it, like bad things happened, right? And so that's this is what I said earlier about like retroactively making that. So like I totally take the feedback that, this abstraction needs to either explicitly say, I don't care about source generation, so do whatever. And then we have to decide that we're okay with that, or we specifically build it in such a way that it does work well with source generation, right? But like, I don't think we should kid ourselves that we can just sprinkle some generic methods later onto this type and have it just work. Especially because, well, how do you implement those methods now? So if you have...
It's very hard. I will just say I would recommend doing the work up front. You will cry far less in the long run.
Right.
For sure, we should get out of our head that just making them generic methods makes it trim friendly. Like it's just not true at all, right? Like some serializers find methods that have certain attributes on it and call it during deserialization and on deserialization, right?
Yep.
Like there's no way there's no way a trimmer is gonna figure that out.
Yeah. No, I mean that's I think a good question in general. Is like even like given that it's that this is an abstraction, like is it always lossy effectively for the type system? And the answer is probably yes, right? But that's, I think, something we should think about. So then, okay, I have a bunch of notes. Let me just paste them in here, and then you can take a look and tell me whether I missed anything. But I think this was a useful conversation. And then I think the follow-up would be, I think the first two was probably the primary one. It's like, okay, for us to judge whether the abstraction is useful, it's kind of like, what's the list of things you would actually implement it for, and then also what were the places that would actually use it?
Yeah, I think it would be good to add those generic methods and kind of do more thinking about how it would integrate with Blazor and other environments that require trimming. Also, I think it would be good to make the proposal a bit more like concrete. For example, which concrete binaries we're putting it in. And maybe there's a kind of progression, a sequence. Like initially, we just put it in system memory data, up package, and then potentially what happens when we put something like this in the core, because it would have implications on, for example, some of the members. Like we couldn't have the overload that returns binary data if it moves to the core.
Correct.
It would have to operate on probably memory of byte, and then the Azure corresponding abstraction. Like one additional thing we would want to do is, since we already shipped the abstraction in Azure Core, we would want, if we add BCL abstraction, we would want our abstraction to inherit from the core abstraction, which also has implication on names. Like the Azure type is called Object Serializer. It would be very unfortunate if Object Serializer inherited from Object Serializer.
I kind of prefer if it were an interface. Like you're kind of stuck with that type hierarchy then? It doesn't seem right. It's one thing.
I mean, if once we want anything to have I guess we have DIMs now, but not for Net Standard 2.0. I was going to say, once we want to have the virtual generic that dispatches to an abstract in terms of object and type, then now you're a class.
Well, I mean, sure. Net Standard 2.0 kind of exists because I don't know. That's a broader conversation.
Right. So, but
do we want to add things that specifically like?
And that is part of the question of a feature like this: is does it need to be Net Standard 2.0 to be successful, or is it okay if it's Net 7 plus?
Or do we want to stick things in the core framework that are specifically constrained to Net Standard 2.0 APIs, even though the rest of our additions are mostly in like .NET 7?
Would the Azure SDK be able to use it if it wasn't Net Standard 2.0?
No.
Right. So then, yeah.
Yeah, but it was purely of does it go the question of is that a mark against it for the core framework? Not do we not want to do it at all, but just is it a mark against the core framework?
I would.
I mean, in this case, it's DIMS, which I know that I still have to deliver the write-up on when we think we might be able to use them, but basically we haven't used them yet. So it's Net Standard 2.0 sometimes forces us into we can't even discuss it anymore. But DIMS themselves have proven to still be a problem for us.
Yeah, I mean, regardless of DIMS, I'm just generally very skeptical with interfaces for things like that, right? I mean, if the interface literally is super simple, it has one method on it, I can see it. As soon as you talk about, oh, what if we want to support other types in the future, you kind of talk about a type you want to evolve. And to me, DIMS are not really as easy to use as, let's say, virtual methods are in classes. And so I would generally say, like, unless there's a good reason, I would not change our guidelines to go from interfaces to from classes to interfaces just for aesthetics, right? Which is kind of what most of the discussions that actually in the past pushed for interfaces were literally based on. It's not, there really isn't a reason why you can't use an abstract class for the most part.
Well, only if you want something else in your type hierarchy for serializer, which seems reasonable.
I don't think
it just means you have to make a bridging type.
Yeah, exactly. Which I think for these kind of things is probably what you want anyways. Because I mean,
fair enough.
I mean, especially when we don't put it in the core, then you talk about.
Yeah, but that's a good reason for not putting it in the core too. Like if we're gonna have to make a bridging type anyway.
Yeah, because like XML serializer is already object or instance based and doesn't do this, so then you would have an XML object serializer that just wraps and forwards to the appropriate name method. So
yeah, that makes sense.
Type hierarchy is just about call patterns. So
yeah, I mean the question really boils down to like, I mean if we want to, like, I think for abstractions it's fine if you're a bit more constrained in terms of, you can't just use the latest feature. If your goal is to have an abstraction that gets uptake by the ecosystem on day one, right? If you build something completely new like Span, where you say like, okay, we're adding a ton of value here, but it will take a while for the ecosystem to catch up, that's also fine, right? But I think the problem is always when you build something that is super sexy, but nobody can use it yet, then the uptake is super, super, super low, right? And that's kind of the catch-22 that we try to avoid. So in that sense, I think even if you put it in box, I wouldn't necessarily say like, okay, let's go out of our way to make it impossible to provide a Net Standard 2 implementation, which I think in this case would kind of look like that in my opinion, because I mean, if you just design it naturally, I think you would have something that just works on Net Standard 2. And then it's just a function of like, do we think that's the right thing of doing? But I did this whole write-up to actually talk about what the trade-offs are, right? And I think I'm not morally opposed to do that, because I mean, there's business value in doing so, and I think that's where we have to make the decision. All right, so then anything else in terms of follow-ups? Christoph, are you happy with the outcome so far?
Yeah, I think it was a good discussion, and I agree. We should work on the details of the APIs and kind of details of the plan, how it would ship, and look back in a week or two.
And the goals and non-goals, especially with regards to linker friendliness.
Yeah, though for the linker friendliness, who would kind of help here with the design? Because
Earhart is probably the expert after doing all that source generation system text JSON work. And then in terms of, the things that the linker can recognize and the features we support, I think I'd be a good contact for that.
Yeah, so maybe we just work in the issue and basically suggest modifications to the API shape for various goals that we just discussed.
Yeah.
Yep. The other thing I would add is system text JSON, the non-polymorphic mode. If that is truly the thing that, I mean, according to our docs, it's the thing we recommend. So we should probably see what we can do about making that also the default when you use it this way.
Sorry.
Well, this maps to that. It's serialize, and it takes an object value, but then the next argument is what type should value be considered as, so that it ignores its runtime type and locks it to that design type.
Gotcha.
Yeah.
That's what that parameter is for.
That's generally what we do for all things that take objects. Like this, I don't think we have a single overload that doesn't take type when it takes object. We try to avoid that for that reason.
Yeah, not in the JSON serializer. Or not in the new JSON serializer.
Yeah. We don't want to repeat binary formatter. All right, so then we have 30 minutes over time, but I think it was a good discussion. I basically put it in 7.0, so there's some urgency. I mean, it doesn't really mean that it only ships in 7.0, right? It can still be in OOP, but in terms of release management, that's how we think about this. All right.
Yep. For context, when we are exploring trimming, serializers are easily the biggest problem.
Yep.
It's something like 60% of all warnings are related to trimming in our experiments. Or sorry, related to serialization when trimming.
Yeah, I mean, I don't know about you, but like I've always hated serialization for various reasons. So if it weren't so damn convenient, we could have removed it a long time ago.
I did make a type-safe library for it, so we'll see if that provides any usefulness.
Yeah, that's my other question, because it was discussed in the thread. So what is the state of that? Like, is this something that we would productize, or is it more like a proof of concept that, how serializers should be built for .NET?
It's my personal project. I can't really put any more emphasis on it than that. I think it's both a proof of concept, and I think it's probably, I mean, personally, I would like it better because it turns every serialization failure into a type system error.
Mm-hmm.
So that is one particular way to program in .NET. If you like getting compile time errors when something is not possible, then you will probably like this library. If you just, like to play it unsafe and do whatever at runtime, then this is probably not for you.
Would you demo that to us at some point?
Yeah, sure.
Because that would be interesting, I think.
I've yet to implement. So it's a port of Rust's Srd, by the way. And it's very similar to the whole idea. It's all source generated. And it's based off of interfaces. The main thing is that serialization is an interface that you have to implement, kind of throw back to the old iSerializable stuff. Mm-hmm. But source generators really changed that game.
Yep, that makes sense. All right, I will talk to you offline whether we can put this on the calendar at some point, because I think that would be interesting to a large chunk of people. And then we have it recorded for all eternity. All right, so then I think this is it for today, unless somebody else has to say something. Thanks, everybody. This was civil so far. I expected more bloodshed.
All right, thank you for good discussion.
Tschüss.